Sir Isaac Newton was born on Christmas Day 25th December 1642 in the country of Lincolnshire. His father, also named Isaac Newton, had died 3 months before. When Newton was 3, his mother remained and went to live with her new husband, leaving her son in the care of his maternal grandmother. From the age of about 12 until he was 17, Newton was educated at the King's School, Grantham, which taught Latin and Greek. His mother, widowed for the second time, attempted to make him a farmer, an occupation he hated. In June 1661, he was admitted to Trinity College, Cambridge. At that time, the college's teachings were based on those of Aristotle, whom Newton supplemented with modern philosophers such as Descartes and astronomers such as Galileo and Thomas Street, through whom he learned of Kepler's work. In 1665, he discovered the generalized binomial theorem and began to develop a mathematical theory that later became calculus. Soon after Newton had obtained his BA degree in August 1665, the university temporarily closed as a precaution against the Great Plague. Although he had been undistinguished as a Cambridge student, Newton's private studies at his home over the subsequent 2 years saw the development of his theories on calculus, optics, and the law of gravitation. In April 1667, he returned to Cambridge and in October was elected as a Fellow of Trinity. He was elected a Fellow of the Royal Society in 1672. Newton's work has been said to distinctly advance every branch of mathematics then studied. Newton later became involved in a dispute with Leibniz over priority in the development of calculus. Newton had been reluctant to publish his calculus because he feared controversy and criticism. The dispute then broke out in full force in 1711 when the Royal Society proclaimed in a study that it was Newton who was the true discoverer and labelled Leibniz a fraud. Newton suffered a mental breakdown in 1675 and was still recovering through 1679. In response to a letter from Hooke, he suggested that a particle, if released, would spiral into the center of the earth. Hooke wrote back, claiming that the path would not be a spiral but an ellipse. Newton, who hated being bested, then proceeded to work out the mathematics of orbits. Again, he did not publish his calculations. Halley, who had become interested in orbits, finally convinced Newton to expand and publish his calculations. Newton devoted the period from August 1684 to spring 1686 to this task, and the result became one of the most important and influential work on physics of all times, Philosophia Naturalis Principia Mathematica, which is Mathematical Principles of Natural Philosophy 1687, often shortened to Principia Mathematica or simply the Principia. The book of one of Principia, Newton opened with definitions and the 3 laws of motion, now known as Newton's laws. Book 2 presented Newton's new scientific philosophy, which came to replace Cartesianism. Finally, Book 3 considered of applications of his dynamics, including an explanation for tides and a theory of lunar motion. Newton's equations also described the motion of moon by successive approximations and correctly predicted the return of Halley's comet. In 1666, Newton observed that the spectrum of colors exiting a prism in the position of minimum deviation is oblong. The prism refracts different colors by different angles. This led him to conclude that color is a property intrinsic to light, a point which had been debated in prior years. From 1670 to 1672, Newton lectured on optics. During this period, he investigated the refraction of light, demonstrating that the multicolored spectrum produced by a prism could be recomposed into white light by a lens and a second prism. From this work, he concluded that the lens of any refracting telescope would suffer from dispersion of light into colors, chromatic aberration. As a proof of the concept, he constructed a telescope using reflective mirrors instead of lenses as the objective to bypass that problem. Building the design, the first known functional reflecting telescope, today known as Newtonian telescope, involved solving the problem of suitable mirror material and shaping technique. In late 1668, he was able to produce his first reflective telescope. It was about 8 inches long and it gave a clearer and larger image. In 1671, the Royal Society asked for a demonstration of his reflecting telescope. When Robert Hooke criticized some of Newtonian's ideas, Newton was so offended that he withdrew from public debate. He argued that light is composed of particles or corpuscles which were refracted by accelerating into denser medium. However, later physicists favored a purely wave-like explanation of light to account for the interference pattern and the general phenomenon of diffraction. Today's quantum mechanics, photons, and the idea of wave-particle duality bear only a minor resemblance to Newtonian's understanding of light. In 1704, Newton published Optics, in which he expounded his corpuscular theory of light. He considered light to be made up of extremely subtle corpuscles that ordinary matter was made up of. Not everyone at the Royal Academy was enthusiastic about Newton's discoveries in optics. Among the dissenters was Robert Hooke, one of the original members of the Royal Academy and a scientist who was accomplished in a number of areas including mechanics and optics. While Newton theorized that light was composed of particles, Hooke believed it was composed of waves. Hooke quickly condemned Newton's paper in condescending terms and attacked Newton's methodology and conclusion. Hooke was not the only one to question Newton's work in optics. Renowned Dutch scientists Christian Huygens and a number of French Jesuits also raised objections. The rivalry between Newton and Hooke would continue for several years thereafter. Then in 1678, Newton suffered a complete nervous breakdown and the correspondence abruptly ended. During his hiatus from public life, Newton returned to his study of gravitation and its effects on the orbits of planets. In a 1679 letter of general correspondence to Royal Society members for contributions, Hooke wrote to Newton and brought up the question of planetary motion, suggesting that a formula involving the inverse square might explain the attraction between the planets and the shape of their bodies. Newton, however, was furious and strongly defended his discoveries. Halley, who had invested much of himself in Newton's work, tried to make peace between the two men. Principia was published in 1687. As Newton's reputation and fame grew, Hooke's declined, causing him to become even more bitter and loathsome towards his rival. He also devoted a great deal of time to alchemy. Newton was also a member of the Parliament of England for Cambridge University between 1689 to 90 and 1701. Newton moved to London to take up the post of warden for the Royal Mint in 1696. He took charge of England's great recoining. Newton became perhaps the best known master of the mint upon, a position Newton held for the last 30 years of his life. Counterfeiting was high treason, punishable by the felon being hanged, drowned, and quartered. Despite this, convicting even the most flagrant criminals could be extremely difficult. However, Newton proved equal to the task. Towards the end of his life, Newton lived at Cranberry Park near Winchester, England, with his niece Catherine Conduit and her husband John Conduit. By this time, Newton had become one of the most famous men in Europe. His scientific discoveries were unchallenged. He also had become wealthy, investing his sizable income wisely and bestowing sizable gifts to charity. Despite his fame, Newton's life was far from perfect. He never married or made many friends, and in his later years, combination of pride, insecurity, and side trips on peculiar scientific inquiries led even some of his few friends to worry about his mental disability. By the time he reached 80 years of age, Newton was experiencing digestive problems and had to drastically change his diet and mobility. In March 1727, Newton experienced severe pain in his abdomen and blacked out. never to regain consciousness. He died the next day on March 31st, 1727 at the age of 87. So friends, I hope you like this video. If you do so, please share, subscribe and like. Thank you.